Because they're both written in general form, what's the best method for solving number 1? Graphing. And when you guys plugged it into your calculator, what answer did you get? 3, 3. Number 2, graphing is not the easiest method because both of them are not in general form. But instead, do you see a variable all by itself? X. So since the x is by itself, we scribble out the other x, but we have to put in something of equal value. So we are going to substitute in a negative 5 minus 6y. So it's negative 3, but instead of times x, times negative 5 minus 6y, minus 5y equals negative 11. Once we've substituted in, we can now solve it, and I see the distributive property with the negative 3. So 15 plus 18y minus 5y equals negative 11. From here, I always like to get like terms on the same side together. So 18y and negative 5y is 13y equals negative 11. And then I'm going to solve it. Subtract 15. And then divide by 13, and I get y to equal negative 2. Now we always have to go back and get the other variable. Which equation looks easier to you, the top or the bottom? Okay. We know that the y is negative 2, so I'm going to plug that in. So my answer is these two lines intersect at 7, negative 2. On number 1, the positive 7y and negative 7y are already opposites, so we are going to add these two equations together. Negative 7x and negative 4x is negative 11x. Positive 7y and negative 7y eliminate. They're gone, so I don't put anything down there below. Not 0, not y, not 0y, nothing. I just leave that area blank. 28 plus 5 is 33. So now this is my equation I need to solve. And to solve this, the opposite of multiplying by negative 11 is dividing by negative 11. And we get x to equal negative 3. Now we always have to go back and solve for the other variable, and just like substitution, there's two equations written in black. We pick the one that looks easier. They'll both work, but which one do you guys would rather work with? Bottom. So negative 4x minus 7y equals 5. We know that x is negative 3. So negative 4 times negative 3. Negative 4 times negative 3 is a positive 12. And from here, the opposite of a positive 12 is negative 12. Sorry, I messed up there. Let me go back. That's a 5. So negative 4 and negative 3 gives me a positive 12. Opposite of positive 12 is negative 12. And negative 7y equals negative 7. Divide, and we get y to equal 1. On number 2, we are looking for opposites, and your eye should have been drawn right here. Negative 5x and positive 5x are opposites. As soon as you see opposites, that's your signal to do addition. So negative 5x and positive 5x is gone. Again, I don't write 0, I don't write 0x or anything like that. It's gone. Negative 2y and negative 4y is negative 6y. Negative 6 and negative 12 is negative 18. And then from here I solve it by dividing by negative 6. And I get y equals 3. we always have to go back and get the other variable. Which equation, the top or the bottom, looks easier to you though? Bottom? So it doesn't matter, you're going to get the exact same answer either way. Y is 3, so I'm going to plug a 3 in for the y. And negative 4 times 3 is negative 12. Add 12 to both sides. And we get 5x equals 0. Divide by 5. And x equals 0. So these two lines would intersect at the point 0, 3. On number 3, we always want to look for opposites. Your eyes should have been drawn to positive 3x and negative 3x. Those are opposites. But also positive 4y and negative 4y. That's your first hint that since you have two opposites, something weird is going to happen on this problem. So since I have opposites, I go to addition. Negative 3x, positive 3x are gone. Negative 4y and positive 4y are gone. I'm left with nothing on the left side. And what number represents there's nothing over there? 0. On the right-hand side, negative 15 and positive 12 gives me negative 3. Now, since there's no variables, I just have to ask myself, is this a true statement or a false statement? And 0 does not equal negative 3, so that's false. So what's my answer? No solutions. Number 5, there are no opposites. But there is the same, a positive 5y and a positive 5y. But we need them to eliminate. So we're going to have to do a little bit of work to get them to eliminate. Rather than using subtraction, because I'm trying to get you ready for the next section, we are still going to do addition. But what we're going to do is we're going to multiply one of the equations, and it does not matter which one. We're going to multiply it by negative 1. Now, in reality, multiplying by negative 1 is just flipping the signals or symbols. So that becomes negative 5x, negative 5y equals negative 10. Now, after I multiply by negative 1 or flip my symbols, however you want to say it, I scribble out the middle equation. Now, do we have opposites anywhere? Yeah. Positive 5y and negative 5y. As soon as we see opposites, we go to addition. Negative 1x and negative 5x becomes negative 6x. Positive 5y and negative 5y are eliminated, so we don't put anything. Negative 8 and negative 10 gives me negative 18. Then I solve this by dividing by negative 6, and x equals 3. Now, we always have to go back and solve the other variable, but in this situation, we actually have 3 choices. The top, the middle one that's scribbled out, and the bottom one. So of those 3 choices, which one looks easiest to you? Top? I think I heard the top. All right, I'm going to use the top as well. Then x is 3, so it becomes negative 3 plus 5y equals negative 8. And then we solve it. Add 3 and divide by 5. And y equals negative 1. So these two lines would cross at 3, negative 1. All right. On number 6, again, we are looking for opposites. But we don't have opposites, we have same, positive 4x and positive 4x. So we need to do a little bit of work to get us to addition. So I'm going to multiply the bottom one by negative 1 or flip all the symbols, however you want to say it. Positive 4x becomes negative 4x, negative 2y becomes positive 2y, and positive 16 becomes negative 16. After I multiply it by negative 1 or flip my symbols, I scribble it out. Now I see opposites, positive 4x and negative 4x. And as soon as I see opposites, I go to addition. The 4x's are eliminated. 1y plus 2y is 3y. Negative 2 and negative 16 is negative 18. Divide by 3, and y equals negative 6. I always go back and get the other variable, and I have three options. The top equation, the one that's scribbled out, and the bottom one. I'm going to go with the top one. And y is negative 6, so 4x minus 6 equals negative 2. Add 6 to both sides, and divide by 4. And I get that these two would intersect at 1, negative 6. On number 7, we are looking for opposites. Well, I see negative 3x and negative 3x. That's not opposites, that's the same. Positive 10y and positive 10y. Again, that's not opposites, those are the same. So I'm going to have to do a little bit of work to solve this one. I always multiply the bottom one by negative 1 or flip all the symbols. That's just a force of habit, but you could do that to the top one if you wanted. So negative 3x becomes positive 3x. Positive 10y becomes negative 10y. And positive 28 becomes negative 28. And then I scribble it out. Again, I'm looking for opposites. I see negative 3x and positive 3x, positive 10y and negative 10y. So since I have two sets of opposites, I go to addition, but I should realize that something weird is about to happen because I had two sets of opposites. On the left-hand side, the 3x's are gone, the 10y's are gone. I'm left with nothing, and 0 represents there's nothing left. 18 and negative 28 combines to give me negative 10. Is that a true statement or a false statement? It's false, which means we get another no solution.